Assalamualaikum warahmatullahi wabarakatuh, and a very good day I wish to both panels, Dr. Nur Sawani binti Saharuddin and Dr. Nur Hafiz bin Salim. I am Muhammad Taqib bin Abdul Manaf, the first year student from BEKG section 3, and today I will be presenting my first part of final year project entitled Frequency Transient Control by using state feedback H infinity filter for power system with single generator. Let's proceed with the introduction. Here, I would like to brief shortly about the frequency control and why it is very important to be monitored. The frequency control strategy is a crucial aspect in power system generation in order to produce a stable output. Because with unstable output frequency, it can lead to major effect on the frequency grid and may cause equipment and infrastructural damage. And here in Malaysia, we have our operating frequency at 50 Hz set by TNB. Basically, frequency control is a process where we maintain the stability in the power system so that the frequency will stay at 50 Hz. In a power system, frequency may increase or decrease, depends on situations. When the load is greater than supply, the frequency can decrease, and in similar way, it can increase when the load is lower than supply. Next, let us get acquainted with the so-called H-infinity method. This H-infinity term came from the name of the mathematical space over which the optimization takes place, the hard disk space of a matrix-valued function. This method needs us to analyze the system to come out with a mathematical model. By expressing the control problem of the system as a mathematical optimization, a controller then can be designed to solve the optimization. Compared to classical control technique, this method readily applicable to problems involving multivariate systems with cross-coupling between channels, although this method needs a high level of mathematical understanding to apply them successfully and the need for a reasonably good model of the systems that we want to control. Now, let's take a look on the problem statement. With the development of power system nowadays, it is vital to stabilize and maintain the quality of frequency output following a relatively large disturbance and load changes arising from the loss of transmission elements or generation facilities. The capability of a power system controller to sustain the frequency despite the major changes will be focused here. So, a controller based on H-infinity method will be designed and simulated by using MATLAB Simulink. Three objectives to be achieved in this project are: first, to develop a mathematical model of isolated power system network consists of one local generator. Second, to design and build up a model of H-infinity controller by using the MATLAB Simulink software. And the last one is to analyze the impact of frequency variation of the power system and the differences when using H-infinity controller. The scope of this project focuses on analyzing the isolated power system with single generator and create a mathematical model from the system. A feedback controller will be designed by using H-infinity approach and identify the capabilities of the controller to countermeasure the error and disturbance in the control area of the power system. MATLAB Simulink is used to verify the H-infinity controller. For literature reviewing part, we will be focusing on two topics, which are state space, state feedback and load frequency control, while the second topic is about principle of H-infinity controller. In the first topic, we got to discover the relationship of state space, state feedback and load frequency control in designing the filter for power system. In control engineering, getting a mathematical model and the state space of the mathematical model from a system is the early step and the root, as stated by Bunpei, Junichi and Ryo in their article in 2007. With suitable state space, the property of the system will be easier to understand and manipulated. Meanwhile, state feedback is a method in control system theory to place the closed loop poles of a plant in predetermined locations in the S-plane. It involves the use of state vector in order to compute the control action for specified system dynamics. As for load frequency control, the main goals are to maintain the real frequency and the desired power output. In case of any interconnected power system, any small sudden load change in any of the areas cause the fluctuation of the frequencies of each and every area, even fluctuation of power in entire line. Load frequency control incorporates an appropriate control system for an isolated power system, which the purpose to bring back the frequencies of each area, the tie line powers back to original point. The second topic is about H infinity principle. The controller uses a method by expressing the control problem as a mathematical optimization problem and then find the controller that solves this optimization. This method is used to synthesize controllers to achieve stabilization with guaranteed performance. Next, we are here on methodology part. In the slide here is the project timeline and also flowchart of this project I'm conducting. For this project, two methods will be used, which are mathematical modeling from the power system to get the state space equation for load frequency control. H infinity controller will be designed based on this mathematical model. The second one is simulation by MATLAB Simulink software. For mathematical modeling part, the system first will be analyzed and figure out its various components. In generator model, the first equation obtained here when the swing equation of a synchronous machine is applied to small perturbation, and the second equation is in terms of small deviation in speed. After the speed expressed in per unit without explicit per unit notation and taking the Laplace transform, the last equation is obtained. In load model, since load on a power system consists of a variety of electrical devices with different type of load, the sensitivity of the motor will depend on the composite of the speed load characteristic of all the driving devices, and the equation as shown in the slide. Prime mover is the source of mechanical power for a generator, and it may come from various kinds of sources, such as hydraulic turbines at waterfall, steam turbine whose energy comes from burning of coal, gas, nuclear fuel, or gas turbine. The model of the turbines relates changes in mechanical power output to change in steam valve position. The simplest prime mover model for the non-reheat steam turbine can be approximated with a single time constant, resulting in the following function. Governor model is the important part of this project since governors are designed to permit the speed drop as the load increase. When there is sudden increase in generator electrical load, the electrical power will exceed the mechanical power input. This power deficiency comes from the kinetic energy stored in the rotating system. The reduction in kinetic energy causes the turbine speed, and consequently the frequency of generator will fall. The speed governor mechanism acts as a comparator whose output changing of Pg is the difference between the reference set power changing of Pref and the power 1 over R changing of W, as given from the governor speed characteristic. After assuming a linear relationship and considering a simple time constant, the S-domain relation is as follows. Here is the state space model for the changing of prime mover power over time. As for the results, the simulation conducted is the state space of the mathematical model of the system by using MATLAB Simulink. From the simulation, the matrices A, B, C, and D are obtained and will be used to design the controller in final year project 2. The figure shown in the slide here is when the single time constant is equal to 0.2. And the figure here is when that single time constant is equal to 2. That's all from me. Thank you. Assalamualaikum warahmatullahi wabarakatuh.